Welcome everyone. Before we even talk about formulas, I have a simple question for you. Imagine you are drawing a graph. If you can draw it without lifting your pen, then the graph is continuous. But if you have to stop because there is a gap or a break, then the graph is discontinuous. Surprisingly, this simple idea is exactly what mathematicians call continuity. Today we will understand this concept deeply before solving the NCERT exercise 5.1. Let's understand continuity with the real life example. Imagine you are driving on a smooth road. Since there are no brakes, your journey is comfortable. This is similar to a continuous function. As the value of x changes gradually, the value of the function also changes smoothly, without any sudden jumps. Now suppose the bridge is broken. Even though the road exists on both sides, you cannot continue driving. There is a break. Similarly, if the graph has a hole, jump, or break at a point, the function is not continuous there. This visual picture is much easier to remember than memorizing the definition. A graph gives us an intuitive idea, but in an exam, we need a mathematical test. That's where three important quantities come in picture: the left-hand limit, the right-hand limit, and the actual value of the function at the point. These three together tell us whether the graph has a break. This is the most important condition of continuity. First, the left-hand limit should exist. Second, the right-hand limit should also exist. Third, the function must actually be defined at that point. Finally, all three values must be equal. If even one of these conditions fails, the function is not continuous at that point. Let's verify these conditions with a simple example. Consider the function f of x equals to x squared. We want to check whether it is continuous at x equal to 2. Since x squared is a polynomial, we already expect it to be continuous. But let's prove it using definition. Approaching 2 from the left gives us 4. Approaching from the right also gives us 4. The actual function value at x equal to 2 is also 4. Since all three conditions are equal, the function is continuous at x equals to 2. This is exactly the process we will follow in the every continuity question. Now, let's begin the NCERT exercise 5.1. In question 1, we need to prove that linear function f of x equals 5x minus 3 is continuous at three different points. Since this is a linear polynomial, it is continuous everywhere, but we will verify it using continuity conditions. So let's first find the left-hand limit at x equals to 0. So left-hand limit gives us the value minus 3. Similarly, if you try to find the right-hand limit, it is also minus 3 because the polynomials have no breaks or jumps. Now substitute x equals to 0 into the function and it also gives us minus 3. Since all three values are equal, the function is continuous at x equals to 0. Now repeat the same steps for x equals to minus 3 and x equals to 5. In each case, the left-hand limit, right-hand limit, and function value are identical. Therefore, the function is continuous at both the points. This illustrates an important fact. Every polynomial function is continuous for all real numbers. Let's move to the exercise 5.1, question number 2. This is another polynomial function. Even before solving, we know that every polynomial is continuous. However, in the board examination, you must still show the calculations to score full marks. Let's first find the left-hand limit. It is becoming 17. And right-hand limit is also 70. Now substitute x equals to 3 in the function, which gives us value equal to 17. Since all the three values are equal, we can conclude that the function is continuous at the given point. Here's an important shortcut. Every polynomial function is continuous for all real numbers. If you recognize a polynomial, you already know the answer. But still, in board exams, don't skip the working. Now, let's solve question 3c from the same exercise. Did you notice something interesting over here? Once you factorize the numerator, the expression simplifies to x minus 5. But at x equals minus 5, the original function wasn't defined. That missing point creates a removable discontinuity. Let's solve question number 9 from the same exercise. At first glance, this looks like a difficult absolute value function, but there is a very simple observation. For all values of x less than 0, we know that the absolute value of x is equal to minus x. So x divided by modulus x becomes x divided by minus x, which is simplified to minus 1. That means for every negative value of x, the function is simply equal to -1. For x greater than or equal to 0, the function is already defined as -1. So both pieces of the function are actually the same constant value. The only point where piecewise function can possibly be discontinuous is where the definition changes, which is at x equals 0. Now let's check continuity. The left-hand limit is -1 at x equals to 0. The right-hand limit is also -1. And the function value at 0 is again -1. Since the left-hand limit, right-hand limit, and the function value are all equal, the function is continuous at x equals 0. Therefore, this function has no points of discontinuity and is continuous for all real numbers. Let's solve question number 12. This is a piecewise function, so the first thing we should identify is where the definition changes. Here, it changes at x equals 1. Both parts of the function are polynomials, and we know that every polynomial is continuous everywhere. Therefore, the only point we need to check is x equals 1. First, let's calculate the left-hand limit. Substituting x equals 1 into x raised to the power 10 minus 1, we get 1 minus 1, which is 0. Next, the right-hand limit. Substituting x equals 1 into x squared gives 1. Now the function value. Since 1 satisfies x less than or equal to 1, we use the first expression. Again, the value is 0. Finally, compare all three values. The left-hand limit is 0, while the right-hand limit is 1, and the function value at 1 is equal to 0. Since the left-hand limit and right-hand limit are not equal, the function is discontinuous at x equals 1. So the only point of discontinuity is x equals 1. In the next video, we will continue with remaining questions from exercise 5.1 and solve them step by step. If you found this explanation helpful, don't forget to like the video, subscribe to Maths with Anu, and share it with your friends.